All stars have a life cycle. They're born, they live, they die, and some explode at the end of their lives. So in this episode, we're going to take a look at what happens when a star dies. Hello, it's me, and this is my channel. Stars are just giant balls of hot gas that shine because their insides are so hot. The reason they able to be so hot in the first place is because of a lot of pressure. A star is born when gravity pulls together a huge cloud of gas and dust. When that happens, the middle part of the cloud gets very dense and hot. Eventually, it gets hot enough to start nuclear fusion. That's when lighter atoms combine into heavier ones, which releases a tremendous amount of energy. And that energy keeps the star from collapsing in on itself. Stars spend most of their lives fusing hydrogen into helium in their cores. When they get old, though, they start to run out of hydrogen, so then they start to fuse helium into heavier elements. But depending on how massive the star was to begin with, it can end up in a number of different states. Let's say our star was relatively small. It started off with about 8 times the mass of our Sun. If it's less massive than that, it doesn't have enough pressure to fuse helium. Instead, it will simply become a white dwarf. It won't actually be white, but it will be small and dense, and it will glow for millions or even billions of years, slowly fading away into the blackness of space. But that's not the most exciting way to go. A more exciting fate awaits stars that are about 16 times the mass of our Sun or greater. These stars end up becoming neutron stars. Our Sun is about halfway between these two extremes. So let's see how it goes. When our Sun runs out of hydrogen, its core will collapse under its own gravity. Its LL gets so dense that it squeezes the atoms so tightly together that electrons can no longer move around to make light. Without light, the core will cool and become a black hole. The outer layers of the Sun will expand greatly and become a red giant. As the core collapses, it'll spin faster and faster until it becomes a neutron star. At this point, it's emitting powerful beams of light from its poles, like a cosmic lighthouse. The Sun will continue to shrink as it rotates, eventually becoming no more than about 20 kilometers across. It won't be glowing at this point. Instead, it'll be emitting X-rays and other high-energy radiation from the charged particles that are hitting the surface. This could happen in as little as a few million years, which is nothing compared to how long it took to get here. If our Sun were even more massive, say about 30 times the mass of our Sun, it would end up exploding as a supernova. Some stars can even be massive enough to cause a hypernova. We think that elements heavier than iron are forged in the cores of these stars. In fact, we might even be able to find gold and platinum in these exploded stars. So those are some of the ways stars can die by becoming a white dwarf, a neutron star, or a supernova. But what if a star had about twice the mass of our Sun? How would that one go? Stars with about twice the mass of our Sun are called B-type stars. They live fast and die young. In fact, most of them don't even live long enough to become a red giant. Instead, when they run out of hydrogen, they'll collapse quickly and end up as a blue dwarf. Blue dwarfs are similar to white dwarfs, only hotter and bluer. These stars may live for hundreds of billions of years before they fade away, but since they're so massive, they never get that small. In fact, they remain about the same size as our Sun. A star with exactly twice the mass of our Sun is called a B2V star. These stars can live for around 10 billion years before they run out of hydrogen. When they do, they become blue giants. They become about twice as big as red giants and about twice as hot. They shine brightly for a few million years, and then they cool off and become blue dwarfs. What if our star were a bit more massive, say 3 times the mass of our Sun? Stars like this are called A-type stars. They live fast and die young, kind of like B-type stars. But they live long enough to become red giants. Once they run out of hydrogen, they collapse and become either a blue giant or a supernova. Okay, now let's jump up a little. Stars that are 5 times the mass of our Sun or greater are called O-type stars. These are massive stars that live fast and die young. When they run out of hydrogen, they collapse and become red hypergiants. Then they explode as hypernovas. Hypernovas are the most energetic explosions in the universe. They can outshine galaxies. It's thought that the biggest stars in the universe are O-type stars. These stars are rare. There aren't many of them and they don't last long, but they play an important role in the universe. That's because they produce elements heavier than iron. These elements are called metals for some reason. Stars can only produce metals if they're massive enough. That's because the pressure in the core needs to be high enough to overcome the repulsion between the positively charged nuclei. The bigger the star, the higher the pressure. We think that the biggest stars ever were O-type stars with masses up to 300 times that of our Sun. These stars would have been around 2,000 light-years across. For scale, our Sun is about 1.4 million kilometers across. So the biggest stars would have been bigger than the Earth's diameter. These stars would have burned through their fuel so quickly that they wouldn't have lived for more than a few million years. But they would have produced a huge amount of metals during their short lifetimes. In fact, we think that the Earth got most of its iron from a supernova that happened nearby around 4.5 billion years ago. The explosion blasted material out into the solar system, and some of it ended up on the young Earth. It's possible that without this explosion, life as we know it couldn't exist. There's still a lot that scientists don't understand about how stars die. That's because it's hard to study dead stars. Most of them are very far away and they fade away very quickly. But there are some places you can go to see them up close. For example, there's a place called the Crab Nebula. It's a cloud of gas and dust that's left over from a supernova that happened 11,000 years ago. You can actually see the supernova remnant today with a telescope. The star that exploded was a pulsar. Pulsars are neutron stars that emit beams of light from their poles. Scientists think that our sun will leave behind something like the Crab Nebula when it dies. Of course, our sun won't explode because it isn't massive enough. Instead, it'll become a white dwarf. White dwarfs are incredibly dense. They can be as much as 1,000,000,000,000 times denser than our sun. If you squeezed our sun to the size of Earth, it would be a white dwarf. White dwarfs can have masses up to 1.4 times that of our sun, but they're only about the size of Earth. That means they're incredibly dense. Here's another fun fact. It's illegal to own a white dwarf. I know that might sound crazy, but it's true. In 1994, an amateur astronomer in Arizona found a white dwarf that was passing in front of a star. He noticed that the light from the star changed in a regular way every 78 minutes. Alright, one last thing before we go. This has been episode number 14 of my Seashell Space series. Want to help us make more? Head over to our support page and join our constellation of supporters. Your support helps us keep making good videos about space. And who knows, maybe one day we'll make one about your favorite space topic. Thanks for watching.